Let's talk about solving equations that have the same base. So an equation that has the same base, an exponential equation with the same base, might look something like this. If we're asked to solve for x an equation 2 to the x equals 8, that's something that might be able to be solved pretty easily just by looking at it. For example, if x were just equal to 3, then we would have 2 to the 3 equals 8. So x should be 3. But I want you to look at this a different way. I'm going to rewrite this 8 as a 2 to the 3 power. That's equivalent. 8 is equal to 2 to the 3. And we have now on both sides an exponential with base 2. So a lot of people think about it as canceling the 2's from here, but the main idea is this. The main idea is that the only way two expressions are equal, where they have the same base, is if the exponents are also equal to each other. So a to the x equals a to the y, means that x has to be equal to y. Those exponents must be equal to each other if the bases are already equal. So in our equation over here, 2 to the x equals 2 to the 3 means that x must equal 3. So what we're going to try to do for all of our equations in this video is get the same base on both sides. So in this case, base 2's. So let's try a bunch of examples like that, and I want to do one more before we clear the page. So let's do 5 to the 2x minus 3 equals 1 over 25. Okay, so remember, my main goal here is to try to get both sides of my equation written with the same base. Generally, but not always, the base that you want to try to write both sides with is the smaller of the two numbers. So looking over here at the 1 over 25, I always ask myself, can I write 25 as 5 with an exponent? And of course we can. We can write this as 5 to the 2x minus 3 equals 1 over 5 squared. Now remember, 1 over 5 squared is the same as 5 to the negative 2. So I can now write both sides with a base of 5. If I had a fraction and I want to move the 5 to the 2 up, that's fine. Just make the exponent a negative. Now I'm technically not canceling the 5's, but it might feel like that when you're solving. We're going to say now the only way that 5 to the 2x minus 3 is equal to 5 to the negative 2 is if 2x minus 3 is equal to negative 2. And I have a pretty easy equation to solve. Adding 3 to both sides gives me 2x equals 1, so x is equal to 1/2. Let's try some harder problems. Here's a cool one. Let's solve for x the equation e to the x squared minus 18 equals e to the 3x. Now, actually, a lot of the heavy lifting is already done here. The left-hand side has a base e, and so does the right-hand side. So the only way that these two expressions can be equal, since the bases are already equal, is if the exponents are equal. So x squared minus 18 equals 3x. Since I have an x squared, I want to get it equal to 0. So x squared minus 3x minus 18 equals 0. And that factors really nicely. X minus 6, x plus 3. So my two solutions for x are x equals 6 and x equals negative 3. Okay, let's make them still a little bit harder. Let's solve 16 to the x equals 8 to the negative x plus 2. Now, at first glance, this one might seem not too bad, but what I want to point out is I cannot rewrite 16 as 8 is the smaller number with an exponent. 8 squared is 64, not 16. So I can't write both of them in terms of 8s, but I can write both of them in terms of 2s. So let's rewrite it like this. Instead of 16, let's see, 16 is equivalent to 2 to the 4th power. And remember, when you have an exponent and you raise that to another exponent, we multiply the two exponents together. So this becomes 2 to the 4x. On the right-hand side, let me write parentheses, negative x plus 2. 8 is 2 to the 3rd power. So here I want to multiply the 3 by the negative x plus 2. So I have 2 to the 3rd, to the negative x plus 2. So I'm going to multiply that 3 through the negative x plus 2, and I have negative 3x plus 6. So I have 2 to the 4x equals 2 to the negative 3x plus 6. Now the only way that that can be true, since the bases are already equal, is if the exponents are equal. 4x equals negative 3x plus 6. Again, a pretty easy equation to solve. Add 3x to both sides. I got 7x equals 6. So x equals 6 over 7. Great. Let's try two more quick equations. Okay, let's solve for x. 9 to the 3x minus 1 equals 1 over 27 to the 4x. Now, just like in the previous example, while I cannot write 9 as some exponent and make that equivalent to 27, I can write both 9 and 27 with base 3s. So that's what I'll do. So instead of 9 to the 3x minus 1, I'm going to write 3 squared to the 3x minus 1. And then I want to do one more step. I'm going to, just like in the last example, multiply the exponent 2 through the exponent 3x minus 1. So this would be 3 to the 6x minus 2. On the right-hand side, I'm going to keep the fraction for now, raising it to the 4x. But instead of writing 27 to the 4x, I'm going to write 3 cubed to the 4x. So this makes 1 over 3 to the 12x. Okay. 3 to the 6x minus 2 equals 1 over 3 to the 12x. They're close. They both have 3's, but I want both of them to be in the numerator. So 3 to the 6x minus 2 is fine, but that 1 over 3 to the 12x, I'm going to make it 3 to the negative 12x. Great. Now both sides have base 3, so the only way that can be equal is if the exponents are equal. So 6x minus 2 equals negative 12x. Subtracting the 6x to the other side, I've got negative 2 equals negative 18x. So x is equal to 1/9. Okay, one more example. Let's solve for x. 2 to the x squared, let me clean that up a little bit, times 8 to the x equals 2 to the 10th. Okay. I love that I have 2 to the x squared and 2 to the 10th. I can write 8 as 2 to the something. I can write this 8 to the x as 2 cubed to the x. So this would be 2 to the x squared times 2 to the 3x equals 2 to the 10th. Okay, so remember when you're multiplying together two things that have the same base, like 2 to the x squared and times 2 to the 3x, you add the exponents. So this is 2 to the x squared plus 3x equals 2 to the 10th. Again, just like all of the problems in this section, happily we have got base 2's on both sides. So the only way those can be equivalent is if the exponents are equivalent. So x squared plus 3x has to equal 10. Since we have an x squared, let's see if we can get 0 on one side and factor. If we can't factor, we'll just use the quadratic formula, but this looks great. X squared plus 3x minus 10 equals 0. Factors to x plus 5, x minus 2. So we have two solutions, -5 and +2. Okay, you might be asking yourself the question, is this going to get harder? And these can get a little bit trickier, but in the next video, we'll be solving things like 2 to the x equals 7, where there is no way to write both sides with the same base. These problems I'm picking here, I'm picking very carefully so that it's possible to write everything with the same base. In order to solve a problem like this, 2 to the x equals 2 to the 7, we need to learn about logarithms.